All right, good morning, everybody. Welcome back to Comp 2450, Software Development 1. I hope that you have all had an excellent weekend. I hope you were able to stay dry over the weekend. It was pretty rainy. This time of the year for me, in terms of like the conditions outside, is my least favorite. I commute by bike to campus each day. And when I leave in the morning at this time of year, it's like it was 3 above, and I have to dress pretty warm to stay warm. Otherwise, my hands are frozen. And even with warm mittens this morning, my fingers are still cold. But by the time I'm going home in the evening, it's kind of like I just have to carry all that stuff home with me. And I really, as beautiful as like the fall foliage is, and like, you know, colors, and it's just wonderful riding in the afternoon, the morning is just so cold. And I hate having to carry that stuff home with me in the end. Gosh, I also hate wet leaves as a biking surface. That's not my favorite time. Anyway, I have digressed pretty far away from what we should be talking about today. Let's talk about implementing flows of interaction. So last week, what we were doing was, here's Pokemon. This is a task that I want to accomplish in this game. The task that I wanted to accomplish in this game was, I want to be able to battle my Pokemon. I want to be able to take my Pokemon and I want to be able to battle it. And in the context of this course, what we're doing is, given an existing system. So I am actually looking at the screen on my display here. I've got Pokemon Yellow running in my emulator, and I'm basically playing the game and reverse engineering this flow of interaction from that game. What we got out of that was a diagram, but what we really want to do is we want to be able to implement that diagram. And that's what we're going to focus on this week, is spending some time thinking about implementing these flows of interaction. Once we've got this diagram, how do we go from that to code? Today, what I want you to be able to do to that end is I really want you to be able to take code and really like ideas that represent code. And I want you to be able to divide this up into different parts of your application. And so the goal that I have for us today, really to this end, is I want to be able to take code, and again, I'm actually not opening up my IDE today for doing coding. I don't really want to look at code here. I just want to think about the kinds of code that we might have, and I want to describe code at a high level. I want us to be able to take these ideas of code and separate these into layers of responsibility at appropriate interfaces. I'm going to define all these terms as we get going through the class, but basically the idea is I want to take this idea of what this code could look like, split it up into separate classes or parts of my application where each of these things have different responsibilities to each other. The goal with this ultimately is I want to make it so it's straightforward to do things like replace different parts of my application. I've mentioned this before. I want to be able to take my text-based UI off and switch it out with a GUI without having to do a ton of extra work. And this idea of layers of responsibility is going to help us accomplish that task. So first, what I want to do is I really briefly want to remind ourselves of this battle flow of interaction, some of the decisions that we made in this. And I want to set the tone for, I want to set the stage for what we're going to be working on in today's class as we're going through and making decisions about the kinds of tasks that we want to accomplish or the kind of code that we might have in accomplishing the task that we've got. So I've got our our flow diagram here in Mermaid. And I'm going to have to ask you to use your imagination here. I don't really want to start up my emulator here because I want to do this from the perspective of I no longer have that emulator to work from. We've got a starting state here. The starting state here is the battle screen. So we're walking around in tall grass. We've encountered a Pokemon, a wild Pokemon. Now the battle screen shows up. The screen fades in and out. It pops up. Our Pokemon slide in from the side, and we're starting to do the battle here. When we're at the battle screen, there are exactly 4 inputs that we can choose from. There's exactly 4. There will only ever be 4, and they always have the same label. So when we built this diagram up, what we did last week was for each of the kinds of things that I can choose from this battle screen, I'm going to just label these as inputs that are provided by the battle screen. So we've got fight here, we've got item, and then in the comment for this, there's a to-do that says to add the Pokemon and the run flows from this battle screen. But again, in this case, there are exactly 4. We know exactly what the labels are from those inputs. So let's just make these be different paths from the system that we've got for now. From there, we started working on the fight selection as the next part of this. And so we went from the starting subtask with the double rectangle here. The input being provided by this screen was fight. And we started to work on the move selection subtask. When we tapped on fight, when we pressed A, we selected fight and we pressed A. The next thing we get to choose from is these are the moves that this Pokemon has. So I want to choose one of these moves to apply to the other one. I want to use this move to attack the other one. From move selection, there's one input provided by that subtask, which is the selected move. This differs from the inputs that we have from this starting subtask in that there are lots of different kinds of moves that you can choose from based on the Pokemon that you've got here. Listing all of those would make this diagram explode in complexity, and we really don't want that. So I'm just going to say this is the move that you selected. That's the input from that screen. Once we have selected a move, now we're moving to one of these processing subtasks. Our processing subtask here as a diamond is do attack. And processing here really means the machine is taking over. Input has been provided to it, the move that's selected. There is some state in this application right now, the current Pokemon that are battling each other. Our system is now going to have the responsibility to make decisions about what to do based on the inputs that have been provided and the state of the application that we have here. So do attack is going to take the move that's been provided as input and then try to use it. The different outputs that we have, so the dashed lines here with the labels, there's the happy path, these 2 outputs. Happy path meaning nothing really went wrong. This is exactly how we'd expect to go through this thing. We've got 2 options. The enemy didn't faint or the enemy did faint. When the enemy did not faint, then we go to this other system processing step, which is to say, I want to switch players now. Going from here to here and then back to the battle screen, we're not getting any inputs. This is all happening in the background. Our system is doing this for us. And so these diamonds are representing basically stages that have no input that's being provided by the person using our software. Each of these outputs now are going to be that the enemy did not faint. We switch our players. The side effect here is that we have switched players at the end, and then we're going to start back at the battle screen again. If our enemy did faint, then we're going to do our battle end. There's stuff that needs to happen in the system to say that this battle has ended. Our Pokemon is going to collect some experience. Our trainer is going to collect some money, possibly depending on the kind of battle that they were going through. And then we wind up at the end subtask here. The end subtask here effectively is saying, you're going to move to some other task in the system now. The other task that we have in this system is you go back to the overworld and you can start moving your little character around and encounter more wild Pokemon or go to a Pokemart or do all sorts of other stuff in this thing. Our do attack here also has a kind of error state. So the no PP left option, I'll come to you in just a second. The no PP left option here, or the output provided by this do attack processing step is, I selected a move, but I can't actually use this move. And so I need to go back to this move selection subtask and basically say, you can't use this move, you gotta pick something else. Then you can choose something else, go back to that processing step and kind of go through this whole flow here. Yes?
Which friends where 5 the game is 2 pair, right? Because the way TDI would be doing everything.
We're pretending that there are two players here, yes. You're right to say that when we were actually playing, like, there was no other player. We'll just pretend that, you know, I've got a Game Boy and you've got a Game Boy and we've got link cables and we're playing a battle against each other. Yeah, yeah, yeah.
The case where we have no PT left, what does that then influence our selection? Is there a way to indicate that you can no longer select one of the items or one of the moves?
Well, so that's a good question, and I'm going to try to summarize. The question is, does the output provided by do attack, which is no PP left, change the way that the presentation is done for the move selection? It can, yes. It very much can. Like the output here can show up on your screen as an error message, for example. You can't pick this move. If we're thinking about how Pokemon is actually implemented, it will show that there are 0 of whatever of this thing left. But that's kind of a technical detail that we're not too concerned with right now. You can basically forbid somebody from selecting that in the first place. That's one option. But for this case, we're just allowing them to select it, go into that processing step, and then maybe tell them an error message to say you can't do that thing, but you're still allowed to pick it. Your question, I'm going to try to pre-answer your question because I think I may be going down the wrong path about what you're thinking about. You might want to gray out those options if they're not selectable in the first place. That's something that you could just do in the move selection subtask in the first place. So before you even get to the do attack part, you just gray that item out and don't make it selectable. But again, that's kind of like implementation detail that we're not too concerned about right now. Did I pre-answer the question you were going to ask? Okay, awesome. Good. Yeah. Would there be any arrows that allow you to go back to the battle select, like the battle starts?
You choose fight, don't want to fight, but it's like the cancel button to choose something else.
Oh, so if you press B here, for example, in the case that we were working with our emulator, there's only one path forward, which is to choose a move. You could say pressed B on move selection and have a line here that goes back to battle screen if you wanted, like the cancel option or the cancel input. But just to keep it simple, I don't really want to put that there for now. Yeah.
It's kind of a general thing. When we have an error output from a processing step, we go back to the subtask that was exactly before it, or like we can go to some others that were before that.
So the question is, if we have an error output from a processing subtask, do we always go back to the previous one? It depends. It really depends on what your flow looks like. In this one, we always just go back to that previous step because that's kind of, we go back to the previous step basically because we are using that specific input to make that decision. I'm trying to imagine a situation where you'd go back 4 or 5 steps or where you'd go all the way back to the beginning again. And that would be a really terrible experience, I think, for the person using your application. It's conceivable that we could say there's no PP left and you just have to go all the way back to the battle screen and then choose fight again. And that would be one way to do it. But because we're working from an existing system and drawing this diagram, that's not how that system worked. And so we're doing it this way. Yeah. Any other questions? Okay, awesome. I really hope I'm inspiring you to go out and buy a Game Boy and like play Pokemon here. I doubt it, but I really hope I am inspiring you to do this. Okay, so we've got our system here. I'm going to go back to my slides here for a moment. I want to start talking about this idea of layers of responsibility. So again, I want to take this diagram that we've got, and the goal that we really have is I want to start making code that does all this stuff. But I today am going to spend a lot more time thinking about how do I take the ideas that are code? I don't want to write code, but I want to think about code. How do I take these ideas that are code from this flow of interaction and start to actually put this down into code. How do I organize this stuff? And so what we've got so far with this system is that we've built up this domain model. And the domain model that we've got for this system represents the kinds of things that can do stuff in our system. We've built up this flow of interaction, and now what we're starting to show is how does the person using my software actually interact with the domain model that I've got in a meaningful way. The REPL that you're implementing for phase 1 is not a meaningful way. This is just a way to make instances of something. Now we're starting to think about how to do this in a meaningful way. Now what? Where do we go from here? I'm going to digress immediately here again. I don't know if any of you have ever tried this kind of cake, but this is something that my grandmother would make. My family comes from Gimli. One half of my family comes from Gimli, which is New Iceland. I have a very small part of Icelandic background. And my grandmother used to make this a long time ago. And she doesn't anymore because she's 96 years old, and this is a very time-consuming cake to make. This is just like layers and layers and layers of cake, and then prune filling, and then cake, and then prune filling, and cake and prune filling. And when people hear prune filling, they're kind of like, ew, yuck, but oh gosh, it's delicious. And this might just be my rose-tinted glasses saying that's something my grandma used to make me when I was a kid, and everybody loves that stuff. But oh gosh. Thank you. Confirming that it's delicious. There's big thumbs up. I see other people nodding. Yes. If you ever take a weekend trip out to Gimli, you can find this in some of the stores. It's expensive, but it's so time consuming to make. It's worth it. I love it. I love it. Okay, so now we got to go play Pokemon, and then second, we have to go buy some Vina Tarta to have for dessert. Okay, so what I want to do is I want to start organizing our code. And what I really want to do is I want to start organizing our code into layers. What we've been thinking about in terms of our domain model is this idea of the single responsibility principle. And I've sold this to you as our domain model objects, as an example, should not have the responsibility of printing themselves. Our domain model objects should have the responsibility of managing their own state, full stop. They should not have any idea of how to do system.out.println. They should not have any idea of how to use scanner. They should just manage their own stuff. Here, we're now going to start taking that same idea, but instead of applying it to single classes, we're going to apply it to big groups of classes. These big groups of classes, I'm going to give them the name layer here. This is what I'm going to describe when I'm using this, when I'm referring to these collections of classes. Each layer is going to have its own responsibility. Not managing a single domain model object, but it's going to be a kind of class. Let's draw out approximately what I mean by this, because me waving my hands at you and saying that we're talking about layers of responsibility doesn't super help here. All right. When I'm thinking about layers of responsibility, I'm going to be thinking about 3 different parts to this overall system. The first part that I'm thinking about to this overall system is the person that's using our software. Obviously, this is not part of the software that we're writing, but this is an actual person that's interacting with the system that we've got. The second part that I want to start thinking about, and I'm going to label this thing as UI. This is going to be the user interface. I'm going to write this really small because I'm going to use the word interface again, and it's going to have a different meaning than what we have with user interface. So I'm going to try to stick to using the word UI to describe this layer of responsibility that I've got here. And the last layer of responsibility that I want us to worry about for right now in this course is going to be called logic. There's 3 different parts to this system. 2 of these are going to be layers: the user interface or the UI layer and the logic layer. These are the 2 layers of responsibility that I want to have in the software that we're writing right now. In between each of these things, I'm going to draw a dotted line or a dashed line here to separate each of these layers of responsibility. In between each of these layers of responsibility is going to be the thing that I'm going to call the interface between these layers. So we've got the 2 layers, and there's going to be an interface that's between them. We've got our human person using our software, and there's going to be an interface between that human person and the software that we've got here. Our human person is going to have an interface that is their keyboard. They're literally clacking on keys here to give input to us. And the way that they are going to be interacting with the UI layer of responsibility here is that they're going to use their keyboard to provide input. They're going to be using their keyboard to provide input to classes that are in the UI layer of responsibility. This is where you're doing stuff like scanner input. I'm sitting at my keyboard, I'm typing stuff in. Your code has a new instance of scanner with system.in here. The user interface, the UI layer of responsibility, has the responsibility to basically take inputs and this is as strings for us in this course, our text-based interface. It has the responsibility to take input as strings and transform that transform those strings into domain model objects. So our UI layer of responsibility will do things like print out, enter this information. It will get that input from an instance of scanner, and then it will have the responsibility of taking that input from scanner and making new instances of domain model objects. Our UI layer of responsibility is going to take those domain model object instances, and it's going to give those to our logic layer. Yeah.
So in this model, who is responsible for validation of data?
The validation is going to be the responsibility of both the UI and the logic layers. Well, we'll talk about that later in the course. For now, we're going to focus on just happy path stuff. And when I'm using this word happy path, We just type in exactly what we're supposed to type in, and we don't concern ourselves too much with problems. I'm going to say that it's more the responsibility of some layer between the UI and logic layer than it is either the UI or the logic layer, because I basically don't want to have to re-implement validation for every different UI that I put up on the screen. But each different kind of UI is going to have to show those results differently. I want to, if I'm typing stuff into a text box, I want to make it red so that you can see which thing it is that has caused the error to happen. If I'm doing this just with terminal or text input, I'm going to just print an error message and that's it. Yeah. That's a great question, though. Thank you. Our UI layer of responsibility passes these domain model objects. I'll come to you in just 1 second. Passes these domain model objects to the logic layer. The logic layer then is going to basically do whatever it's supposed to do. So doing whatever it's supposed to do here effectively means side effects to domain model objects or internal state. Our logic layer of responsibility itself may have some internal state that represents kind of where things are in the application, how we proceeded, gotten to this point, the things that have been passed to us, the things that we provided as output, keeping track of where we are in terms of how things are going. Yes. So the question is, does the UI have the responsibility of telling the logic layer to update existing instances? And I'm going to say yes, it has the responsibility of telling it to update it. And that's what the side effects here are meant to be about this, or modifying internal state. The logic layer may have the logic layer for now will have the responsibility of maintaining the state of all the things that you have in your system. And so it will be the UI's responsibility to say, you need to update it. And it may pass an entire domain model object to reflect, the change that wants to be made. Here's the updated thing. Just put this into your state right now. And then the logic layer will take that as input and just replace whatever exists. It may be that you want to write something that is change the name of a book, and then you would pass just the string. But for us, at least for the purpose of drawing this diagram, the communication between these different layers is effectively going to be domain model objects that are being passed around between them. Yeah. So we have these side effects to the domain model objects that we've got. We've got changes to our internal state that may be things like we're keeping track of everything here. And what we're going to send back from our logic layer of responsibility to the UI layer of responsibility is domain model objects. This is what was changed, and this is how I changed it. We may need to add new domain model objects to represent the change that has taken place here. There may be new domain model objects that come from the operations that you're trying to do in the logic layer, so that your UI layer has the responsibility of effectively only having the responsibility of printing or displaying these domain model instances. Printing or displaying here is pretty much taking those things and putting it up on our monitor or display so that our human person can actually see what's happened as a result of this thing. Our logic layer here has no responsibility at all to do printing. It has no responsibility at all to do user input. It should not know how to transform strings into domain model objects. It doesn't need to do that because it's being provided with domain model objects. That is how it's getting its input. The responsibility of our UI layer of responsibility here is very much take input from the user, from the person that's using my software. I get strings, I get integers, I get whatever. I transform that into class instances of my domain model, give it to the logic layer. The logic layer does its thing, tells me that it's finished, and then I print it back out again. My UI layer of responsibility does not do any application logic. There are no rules to games here. There are no ideas about how I should be able to check out a library book. None of this will happen in the UI layer. It all happens in this logic layer of responsibility. We all okay with this? Yeah.
Explain the dotted line between different classes.
Of course. The dotted lines that I have between each of these things are meant to represent the interface between the layers. This word has now been overloaded about 4 different ways. There is the literal interface type in Java. There's the idea of a user interface. And now I'm adding an additional meaning to all of this stuff. Here, this might actually literally be the interface type in Java. But more generally, what I mean by this is the interface between 2 layers is going to be how they touch each other or how they communicate with each other. So good examples of interfaces here. I'm going to hold this up, and I don't know that all of you can see this, but USB is a kind of interface. When I plug in this mouse and unplug this mouse, my system is going to have a mouse or not. And the interface that I have here is literally this USB connection that I've got between the 2 things. Here, in my logic layer, I'm going to have classes, more than one. I'll have many classes. They're all going to have public methods. The public methods are effectively what the interface is for my logic layer classes. My UI layer classes are going to interact with my logic layer classes by calling those public methods. My user, the person using my software, is going to interact with my UI classes by typing stuff in on the keyboard and reading the text as output that shows up on my screen. I am not likely to use actual interface types here. This is something that we could use, and as we proceed to persistence, this is something that we will use because we're going to add another layer to this eventually. But with this domain model logic stuff here that I've got, I'm not likely to want to switch these things out. This is my application. This is the core stuff that I want to have here. The front end, I probably want to change. Where I put stuff in the end, I probably want to change, but this is the core idea of the thing. So to sum this up, the gray lines, the dashed lines here, these are the interfaces. With the logic layer, it's public methods. These are all the public methods that I can call from that UI layer classes. Yeah. Okay. Any other questions about this right now? Yeah. That's a great question. The question is, will the UI and logic classes be in different packages? Absolutely, yes. So I want to try to physically organize all of my logic classes to be in one package. This is going to be separate from my domain model package. This is going to be separate from the classes that have the responsibility of doing user interface stuff. Within my UI classes, they're all going to go into a UI-like package that represents a physical organization, that these are all related to each other in that they are responsible for doing input and output in my system. Yeah. Okay. All right. The key things that I want you to take away right now are that the UI layer of responsibility is explicitly responsible for taking input and transforming to domain model objects. It is explicitly not responsible for doing anything that is part of the application logic. It should not encode rules at all. All of the rules that you have in your system are being pushed into this logic layer. The logic layer explicitly does not have any responsibility for doing any input or any output. There is no system.out.println. There is no scanner here. We don't do any input or output. Anything that's provided to us is a domain model object that's already been constructed by this UI layer. I will give back instances of domain model objects or other stuff to the UI layer, and it will then have the responsibility of printing that output for my user to be able to see. Okay, I will share this diagram with you after class. I'll put it up on the course webpage. What I want to do now is I want to start taking the time to take this battle flow of interaction and starting to think about where different parts of this are going to go in my system. So I'll hold this up for about 10 seconds, and then I will switch over to Mentimeter, and I'm going to ask you questions about these. I've tried to give some of these questions that I've got in the Mentimeter a little bit longer time to respond. And I've tried to turn off, I may have forgotten to turn off in some cases, but I have tried to turn off the fastest answer wins category. If you want, I would be really happy if you were to talk to each other about these decisions. You'll only have 30 seconds, but to talk to each other a little bit about it, and then we can all talk together about it after. So I'm going to pop over to Mentimeter here. And what I'm going to show you now is the first thing that we're going to be asking questions about in terms of classifying ideas of what implementations are going to be as part of this is the battle screen itself and the inputs that it provides. Here is our very first question. All right, okay. First of all, I'm really delighted that you were actually talking to each other. Thank you for that. UI, I think, is a solid first choice here. I really do think it's a solid first choice here. What I'm going to say is that there's actually a tiny little bit of logic that's part of this. There's a tiny little bit of logic that's part of this. And so I want to say that this actually belongs in classes that exist in, one of them will exist in the UI layer, and one of them will exist in the logic layer. So we'll have two different classes here that we're going to create as part of this. Here's another question. So you got 30 seconds. Feel free to talk. Okay, awesome. Yes. I could hear people saying this, getting input, and I'm so delighted that we're sticking on this. Our UI layer responsibility explicitly has the responsibility of getting input. That is its primary responsibility. Yeah.
I understand why initializing the backend is also included. Would initializing and creating be a part of the logic side?
When I'm using the word initializing the battle here, what I'm effectively trying to say is there is a battle class, and the battle class itself actually doesn't belong in this layer, but the UI class that I make does have the responsibility of making a new instance of this logic layer class that I've got. So the battle class itself, this is what I'm going to call the logic layer class that I've got. The UI layer class is going to be like battle screen or battle display or something like that. And these two classes are going to start talking to each other now. So the input, again, I'm really delighted that so many people have picked this. The other thing that it does have some responsibility for now is beginning to initialize the logic layer so that it can communicate with this logic layer of responsibility.
So I thought that we would be passing instances to the logic.
Yes.
So making an instance of input, isn't that?
That's a fair point. The point that's being made is I thought we were supposed to have instances of classes. I'm going to ask the question here, does it make sense to make an instance of the word fight? Does it make sense to make an instance of the word item? Does it make sense to make an instance of the word Pokemon? And does it make sense to make an instance of the word run? I'm going to say probably not. The kinds of inputs that we'd be expecting here is I've taken the word fight as input, and I'm going to do something about that, but I'm not making any instances of classes here beyond initializing the battle thing itself. Yeah.
You're saying just the fact that we're already in the battle screen in that context, it doesn't make sense to me.
Yeah, so we're already in the battle screen. When we get to the point of if we were to do the item selection, it would be taking, like, I want you to choose item number 5 and then transforming that into a potion or a heal burn or something so that you could pass that to the logic layer. But in this case, the only 4 outputs that we have, inputs that we have provided by the battle screen are like choosing what to do. So fighting or choosing an item or picking a Pokemon or running. Those are the only 4 things that we have to do. And we don't actually have domain model classes that represent those ideas. Those are just actions that we can accomplish in this thing. Yeah.
All layers of responsibility are going to be like using the UI to logic, or is there any like intermediate layers?
So there can be. I am prescribing this to you because I want you to follow this pattern in this course. As you get to later courses, there will be lots of other ways to accomplish the same tasks that we're doing. This will be basically one tool in your tool belt to start accomplishing these tasks. Yeah. Yeah.
So when you said that the battle screen could be like some part of it can be UI and the other logic,
Yes.
doesn't it contradict with the responsibility that logic should be separated from UI? So it should be belonging to either one of those and not both.
And so what I'm trying to get at here is that this battle class will reside in the logic layer. There will be a separate battle screen class. So we'll have 2 classes here, public class battle screen and public class battle, and they'll have separate responsibilities. But by the time we arrive at this battle screen, both of those things have to be ready for us to start working with. They both have to be there. The battle itself, the logic battle has to be there so that I could start calling public methods on that thing. Yeah.
If making it to the input doesn't belong in UI, where would it belong?
It does, but the point I'm trying to make with the UI at this point is that item as a task is not a domain model object. Pokemon as a task is not a domain model object. This is how we get to the choosing Pokemon screen. This is how we get to the item selection screen. I haven't gotten to item selection yet, and I haven't gotten to Pokemon selection yet. I also haven't gotten to move selection yet. So I can't take input and transform that into things that we actually have in our domain model yet. These are just paths that I can take through the subtasks that I've got. So I'm going to go to the next question because I think that we'll get more to like actually doing what we're hoping to accomplish here. Okay. Okay, all right. Okay, good, yes. In this logic layer class that I'm thinking of here, the part of set up the battle is that we're going to have to keep track of what state our battle is currently in. The battle is either still happening, our Pokemon are still not fainted, because Pokemon don't die, they just faint. Our Pokemon are still not fainted. They're still attacking each other. There's still stuff happening here. And so keeping track of the battle state is a good thing to do in our logic layer. Keeping track of currently selected Pokemon is also something that makes sense to do in our logic layer. I'm going to initialize this battle, and I'm going to tell the battle, these are the trainers or these are the Pokemon that are currently interacting with each other. The logic layer then will have the responsibility of keeping track of what Pokemon are currently doing the battling here. In my mind, it's kind of like it might make sense to put that in the UI layer, but I actually want to make sure that the logic layer is responsible for tracking that, because if I make changes to the UI layer, if I take this UI text-based UI layer and I switch it to a graphical-based display, I don't want to have to re-implement all this current Pokemon stuff. I want to ask the battle, who is the current Pokemon for player 1 and who is the current Pokemon for player 2? Yes?
When you made the diagram earlier, you wrote that domain model instance of path from logic to UI. So would that making instance of input, would not that be a part of logic as well?
That's fair. The thing that I have here that I'm going to point at specifically here is that this is the logic layer, and the logic layer explicitly does not have the responsibility of getting input from the user. We will never have scanner in our logic layer classes. I don't want to have system.in here because I don't want my logic layer to even know that it has been provided with input that has been passed to it by a keyboard with system.in. It shouldn't know or care how that input was gotten from a person using the software. It should just know that it has an instance of a domain model object already.
If it just said making instances of items like you said, that would be valid for logic then?
If it's making instances because you're shopping, for example, possibly that's something that would happen in the logic layer. But in this case, in our battle screen, it's not really going to make any instances at all. Yeah. Okay. We've got a few minutes left, and so I want to keep going with this because I think we're like making some good classifications here. I want to move to this move selection part. So after I've selected fight from the battle screen itself, now we're going to choose what move we're going to work on. So my first question that I have here is about this part of the setup. The question I'm really asking here is, when I choose the word fight, where does the code for that belong? Okay. So when I choose the word fight here, I've already initialized my battle class. And I've typed in the word that I've been prompted. What do you want to do? Fight, run, Pokemon item. And I've typed in the word fight here. I don't actually need to tell my logic layer class anything at this point. I don't need to say anything to it. It's already been established that there is 2 Pokemon that are battling each other. There are current Pokemon that are selected for this thing. The state of the battle is in progress. I've just typed in the word fight. And now what I really want to be able to do is start thinking about what should show up on the screen as a result of that. And what shows up on the screen as a result of that is going to be something that may be informed by questions I can ask about the state of my logic layer class. But I don't really need to do anything with my logic layer class here. I'm going to move to the next question. Oh, no. Okay, you did good. Thank you. Yes, excellent. Yes, I can't actually see what's on my screen anymore. This is really what I would say is that once I've typed in the word fight, now I'm going to have to print. I'm going to have to print out. So layer of responsibility is my UI layer of responsibility. Print out. These are the moves that you can choose from. Which one do you want? And then get input from my user so that I can start transforming that into a domain model class. I'm going to keep going with this next class because I think that this is a valuable exercise. What I'm going to quickly do here is pop over, and at this point, you should be able to start to do some of this idea of separating these ideas that we have from our flow of interaction into different kinds of layers of responsibility. That's it for today. I hope you all have a great class. I'm sorry if the stream got messed up at the end. I'll see you all on Wednesday. Bye, everybody. Just give me 1 second here to try and figure out. Oh my God. That is awesome. It is so big. It is so big.